Okay, so obviously I'm being dumb here, right?
Well, I don't know that you're being dumb, actually. It could be that I'm not understanding the question and I'm answering a question that is completely useless to you. So that is also a
Okay,
very high probability. Let me just tell you what I was trying to say
but
first.
before that, let me just say this is all
Okay.
super stupid. This is all just me being lazy and tired because I'm on stream. But like, very obviously, I can construct a matrix that's at the position of the entity, right? With a
Yes.
plane oriented the right way that like multiplies by -1 along that plane. That is just not that
Yes.
hard. I could just sit
Yes.
down and do that from first principles. For some reason, I'm wanting to do it as an incremental change from what I had. So whatever, but it should work either way, honestly. So
Yes.
yeah.
So here is, first of all, I was going to say exactly what you just said. I was going to say, look, if you really just don't care, why not just take an arbitrary axis and flip the thing around it? As long as you have some point that you can send down to flip it around, that's really all you need, right?
Yes. Yes.
But that's a separate thing. So the question I was trying to answer, which may not actually be what you wanted, because since I don't know the structure of the program really, I'm not in a position to say whether this is what you wanted or not. But what I was trying to answer was, let's suppose that we're just going to negate the y at the like vertex stage before we do anything. And so that's what I thought I saw you doing before, where you're like, if is reflecting, we're just going to take the y and negate it.
Yeah.
Right?
And so the way I was thinking about that was just like, look, if you imagine the mesh wasn't animated at all, right? For example,
Yes.
then obviously if you flip that direction in object space before you do anything with it, you'll have a reflected mesh along a known direction, right?
Yeah.
Etc. So that was why I did it that way originally. But the problem is that then affects rotation afterward.
Yes.
And so then I had a bunch of gameplay code to compensate for that, which was fine for a while. It was totally fine. But
Right.
now it is becoming inconvenient. So I want to clean out the gameplay code. Like, the gameplay code was full of like negating the actual gameplay direction that something was facing in order to compensate for this reflection. And that's just not a good thing to do, right?
Right.
So I'm just trying to push it down into rendering and fix it.
Yeah. So all I was trying to say was, if you negate y, right? So if you negate the y in your mesh, and now what you want to do is you want to apply all of your transforms and have them work as if you had done the mirror at the end, right? Then all you have to do is the similarity transform that I put down in that email. So that's how you can use matrices after the mirror and have them behave as if you'd mirrored at the end. Now, that may have no practical utility to you, right? It may be that that's completely unrelated to what you were trying to do anyway. But that's the math for it, right?
Yeah, and I know, I've done that kind of thing enough to know how that goes.
Yes. So what I'm not 100% sure about is why you were saying that it renegates, but also the other thing I'm not sure about is I didn't actually get to see the bug you're actually trying to solve. Like, I'm assuming you have something on the screen that's like, this shouldn't look like this, and I didn't get to see that, and if you could show me that, it might help.
I didn't ever get to that point. What happened was I got to the point of typing in the thing that looked wrong to me, and I was like, I'm not even going to run this because it's not right.
No. I mean the original thing. So when you were just negating the y and only doing that in the mesh, so you just did the reflection, what was wrong?
The original thing is really weird, and I don't completely understand it, honestly. The original problem is, it gets super complicated, but when somebody is reflected, okay. So at any given time, there's a gameplay direction for a character, right? And that is snapped to 90 degrees.
Yes.
Right? Because that matters for like puzzle solving, right? And then there's, what's my visual direction? And that interpolates over time, right? And then of course, to zoom out one level, what I was going to do is, historically, that thing that manipulates both that visual angle and the snapped angle was outside of this transaction system that I've been making to make the gameplay stuff more robust. But obviously, if the gameplay angle matters for gameplay, it should be in the transaction system, because like then all this stuff about backing it out and whatever, right? So I'm just trying to move what handles it. And in the process of moving that, I was like, oh yeah, there's all these negations everywhere. And in addition to, I'm going to have to handle all these more complex transaction situations. So let me get the negations out so it's simpler, and I'm not going to have all this weird stuff in there, right? So that all makes sense. So I took the negations out. That was step one. And to my surprise, and maybe I'm just not thinking the right way about it right now, to my surprise, the actual angles that the character is facing without the negations are correct. So like if I move south, I'm facing the right way. If I move north, I'm facing the right way. But the intermediate angles that we rotate to get there are not correct. Now, there's a complication. And actually, the reason it's wrong may be 100% in the complication. So what we've been talking about might be the wrong thing. Okay, so there's actually two interpolation mechanisms is the complication. One of them is exactly what you would think. There's some code that says what's theta current, what's theta target. If they're not the same, take the frame time and multiply the delta in the proper direction and all that stuff, right? The other one is animation controlled. And this is where it's getting confusing. And now that we're talking about this, it's like, maybe I should turn off the animation control or something to simplify the situation. Because, so the other way is, okay, if the animation says it wants to control turning, then we look at what was our theta at the beginning, right? And then the animation has like relative theta that kind of creeps in over time as it plays. And then at the end of the animation, we like say, where are we? And then we'll kick in that interpolation to clean up any slop that's at the end for whatever reason, if we like bailed out of the animation early or something like that, right? And so I feel like what's actually happening here, so I don't know if you're watching the stream right now, but like
I am.
I can slow down time. This guy is mirrored right now. And so if he turns, he's like, see that the animation is kind of turning one way, but then the I kind of feel like I don't know, man. Anyway,
I see what you're seeing there. So basically, like he started rotating one way, and then he rotated the exact opposite way for his full rotation.
Yeah, or like say, so if I'm here and I'm going to turn left to walk north, right? So he's actually playing the animation for the opposite, like he turned his head to the right instead of to the left. Because if he's not mirrored, okay, so so I'm here. I'm going to turn. Well, let's keep going the same way. So I'm facing along the x-axis, right? So I'm going to turn 90 degrees. So I'm walking north, and so he's going to turn his head to be over the shoulder, right? And the reason is because if I go mirror him back the right way, right? So now he's unmirrored, and he's facing along the x-axis, and he's going to go north. The reason he's turning his head that way is because like that's where his shoulder is. And so actually maybe the bug isn't in rendering at all.
I was just going to say, it sounds like its animation selection is the problem there, right?
Yeah, maybe that's really the only problem.
Because like if you're mirroring the mesh, but you're leaving the outer transform the same, then that means that when you pick a turn left, it's actually a turn right, but you're still turning left. So those will conflict because the thing that picks the animations didn't flip which one it picked, right?
Yeah, the problem is, I have layers of systems here that I did over time. And again, like I've said on the stream, while I'm working on 4 frickin' programs, right? So my
Yeah,
concentration on these things is not nearly what it should be, right?
Oh yeah.
But I'm trying to
I know what you
remember.
mean.
So there were all these negations for your actual current theta, and then I also had negations for when the animation system asks, like, what is the current thing? And I could put those back in. I could just negate like what I report to the animation system. Like the way this works is there's a variable that you can query that says, what is my current like, what would you call it? Just cosmetic facing direction relative to my target direction, right? And so when I start the movement, my target direction is like 90 left, and my facing direction is where I started. And so the relative direction is like 90 to the right. And so it plays that particular thing.
Yeah.
And so I can go back and lie about that again very easily. I can go into this file and I can just remove, I can just Control Z and Emacs and remove all the things that I did that, whoops, now we're back into the previous thing. So I can do that.
So one thing so I had to go back and work it out because I don't quite remember, but also my recollection of like the math that's in that email, for example. So the place that was typically applied was specifically when you were doing export things and wanted to change the coordinate system. So for example, if somebody said they wanted Y to be up, but it came from a file where Z was up, and so what you want to do is you want to transform the mesh, but then you need all of the other things like skeletal animation and everything to now work with the transformed mesh that's been transferred into that coordinate space. And so I think that generally speaking, if you just want to mirror something and have all the rest of the stuff work properly, then I think you can probably just do what I was saying with the similarity transform. The problem is it would mean you'd have to do it to your entire skeletal animation system, which just isn't very interesting, right? And so presumably the correct or easy solution in this case is going to be that you have to have the animation system just pick the opposite animation, because otherwise you're going to have to transform all of the animation stuff to know about the mirror, which seems like a real waste of your time. Know what I mean?
Yes. So anyway, so I'm running with me putting that toggle back in, right? It's still messed up, but now it's messed up in a different way, which again is maybe not that surprising. So, I mean, I'm facing along the x-axis, and I'm going to go north, and you know, he turns his head now in the right way, but like the character rotates the wrong way, and that's going to be the animation-driven control. And so the way that works is I sort of pre-process the animation at load time, and I pull out like what is the d theta dt for each thing. And so I guess I would just negate that. I mean, I kind of feel like I'm not thinking that hard about this and just pushing minus signs around, but I mean, that seems right.
I don't think so. I mean, just to be clear, so the minus sign that you decided to put in there, which was I'm just going to flip things along Y, so that's just a decision minus, right? You're just saying, look, this is where I choose to implement my mirror, and you're allowed to put that anywhere you want, right? I mean, there's no...
I mean, so I'm keeping it Y. Actually, some people were asking this in chat too, so I could explain it. So the coordinate system that I like to use and that we're using in this game for characters is that X is forward, right? And Y is left and Z is up. So it's a right-handed coordinate system where the x-axis is forward. And the reason I like that one is because, for example, the identity rotation or the I don't know, maybe it doesn't make sense to explain it that way.
Well, so but all I want to say about that -1 though, right, is once you put in the -y in your coordinate system, what does that do? Because you could do a -x, -y, -z. Well, the -y turns all clockwise rotations into counterclockwise rotations and vice versa. So it's not like hand waving at all to then go say, well, if previously we were looking at things and looking at how far they'd have to rotate, when we play back an animation, that animation is going to rotate in exactly the opposite direction around Y, because that's what, I mean, direction around Z, because that's what we negated. We negated the XY plane. So that doesn't feel like pushing negatives around. That's just literally the consequence. So I feel totally comfortable with that. I don't know, maybe you don't.
No, that's probably okay. So The code that does this then is, this situation. This is actually what the original code was. Now, I think this theta base is like your gameplay. I should go look at what that is before I blindly... Let me close my Wolfram Alpha window and whatever. So before I go blindly stab at that, I'm just going to look at what that is. But I believe that's a variable that the animation player records when it starts an animation. So we say that our theta base is not initialized, and then if the animation says that it controls turning, this is in blend out for some reason, which is weird. This is the normal one. I have to go look at that too. But basically, when we're doing an animation, if we have a channel and it controls turning, then if this isn't initialized, it means let's grab the theta that the character is facing at the start of when this animation first became engaged, right? So we save this theta base is theta current, which is the visual angle of the thing, and then we set initialize so that we don't do this again. And then we say, oh, here's the channel that's controlling the animation, right? So this is the gameplay angle. So we wouldn't want to negate that because that didn't come from the animation data. But let me see, do we use that any other way? Okay, and then theta offset is coming from the channel, and that's in the animation. We like compute that actually at load time right now, but in theory we would bake it into the asset. And so we just interpolate between frames, or we point sample it if we're not, and that's just in the data. So we don't really do that much. And let me see if we have a theta base here. We don't, right? So the theta base isn't even used in the animation system itself, except to record it so that this code here can use it. And so if we're mirrored, let's just say theta sine is 1.0. If we're mirrored, theta sine is -1, right? And then we're going to say theta current is this plus theta sine times that, whatever. I don't know. I don't know if it's better just to, hard code it, but let's see what that does. I didn't think that hard about that, so it's probably wrong. Anyway,
so it's a little hard for me to follow because, of course, the Twitch stream is lagged.
Oh, yeah, and it's not a programming language that you use, so,
Well, I was just going to ask one question, which is, so where is it getting picked, though? Like, how do you pick which animation to play? I'm confused about that.
Okay, well, let's go look at that since this is an educational stream. Actually, right before we go look at that, I'll point out that this is working a lot of the time. However, if I do some really fast stuff, it was turning the wrong way, and I'm not sure. See that? He did like a 360, like a sick turning rock. He's doing like some... That might actually be bugs in the animation graph, like, because maybe he was doing weird stuff to compensate for the fact that it was wrong. Maybe not. But like once in a while, he does a sick 360, and so...
Yeah, I saw that, yeah.
We could look at that. Like, I don't even know what happened there. That involved some instantaneous teleports, which should never happen. So we're going to have to look at that. But the way that all this works is data-driven. So there's basically a finite state automaton that controls animation states where the gameplay code sends messages or sets values of variables. And then the animator controls that from a file, which, maybe he would have an Unreal Blueprint graphical thing in an engine that wasn't me writing half of it, while doing too many other things. But for now, the plan was like, look, it's just a text file. And then once we know what we want for next game, maybe we build a graphical version. So there's this state machine where there's like all these states, and he just like writes all this stuff. There's like a lot of this right now. It's like 1,000 lines. And it's like, okay, each state, it just starts with a colon. Here's the name of the state. Here's the animation. These are very simple, but they could have like, going to other states on conditions, or they could ignore animations, or they could include other states and whatever. And so, for example, you find somewhere that, okay. I want to find somewhere that uses this target angle value for something besides an ignore. It's probably,
Well, so yeah, I mean, if that's what's happening, that,
okay.
I mean, it scares me a little bit, right? Because
so this kind of thing.
I thought, what?
I'm just going to say, so on the screen, I don't know how long it'll take to get to you, but there's all these like, here are some rules about transition to these different animations based on what target angle is, right? Where target angle is a signed difference between your current angle and what we actually want.
Right. So let me just tell you why I'm scared, having seen this. And I don't know enough about the system to know if my fear is warranted.
Yeah.
So what I thought was happening, or just from the zero knowledge that I had, was that like you had a bunch of animations sitting in like a bin, and your system was going, oh, I'm keeping the rotation of this guy, and I just need to know like which animation to play based on the gameplay angle. So I'm going to like go look up in the database and say, oh, okay, he's going to turn like 90 degrees to the right. So I'm going to go look up what the 90 degrees to the right animation is and play that. And so what I was saying is like, well, it should be fairly straightforward now to just go 90 degrees to the left instead and play that animation, and that would work, right?
Yes.
But in my assumption, my fear then when looking at this is like, well, okay, so the person who made this is just encoding arbitrary stuff in here. So at some level, they've probably only patched over the number of things that they actually needed to handle for this particular target angle branch thing. And then a bunch of other stuff that just worked by blending them together was probably just coded into the thing like however it was coded. And who knows if those things will line up if we start picking them by negating just the target angle, but everything else doesn't get negated. Do you know what I mean?
Sort of, but I'm not sure that I see an actual concrete problem with it. It's just
it's just a fear. So that was just a fear.
Yeah.
So that said, I was just going to say like, so that's the thing that I'm not sure about, but it does seem to me like, well, okay, if I imagined in my head that I'm negating the animation, like, so the animation is now mirrored. And so I need to, when I'm turning in one direction, I need to play the opposite sort of, I need to play the opposite winding of the rotation so that it rotates in the right direction. In my head, that sounds like it still works, but it's also one of those things that I would probably need to actually sketch out to see if that really does work. Do you know what I mean?
Yes.
Because I'm just sort of
I think it does.
Hoping that it does, but yeah.
I think it does.
Okay.
I'm not sure, but I think it does.
Okay, so anyway, sorry to interrupt with that. I was just saying that was what I was worried about, and I'm like, so I got to go convince myself that that's actually true.
No, I get you. I mean, basically what this is supposed to do is basically what you said, except it's just not a straightforward database lookup, right? It's like some stuff. And I suppose there could be something in here that's really wacky and weird. I guess that's quite possible. But I actually suspect, so one of the things that I noticed earlier in the stream is that the angles I was reporting were not clamped to the intervals that I thought they were, right? And so now I'm kind of wondering if some of these if statements are breaking, because especially now that I've changed the range that things were in, by like doing
Right.
some of this stuff. So let me just
Like
check
something's
that.
270 or something and should never be 270, right? Or something like this.
Yeah, and I only really noticed that. So like I was here and I did this. So usually if I go into the editor, right, this is just loading the save game data. This is the level at the beginning as you would start playing it, right? But if I hit magical keystroke combination Control-Alt-Shift-G, right, I load the actual gameplay state.
Right, the standard key combination for loading gameplay state.
Yeah, it doesn't like load everything. Like he's not in the right animation pose and stuff, but his entity data is correct. Oh, and now it's 90. But before it like wasn't 90. So like I don't know what was up with that.
Can you draw that in those little hover windows you've got? Could you just draw his theta current and theta target in those hover windows that were hovering before?
Yes, I could. And so before I do that too, though, I've got a very easy repro here, right? So like if I go right down and I buffer the keystrokes, it's messed up, right? So that's great. He's facing right to start, and I'm turning time down, I'm gonna go right down. So he goes there. Okay, that time it didn't break, which is weird. Down left. So I wonder if it has to do with like frame timing, like whether something else gets the chance to interrupt and break it. So right down. No, it didn't do it. Right down. Okay, maybe. Okay, if he starts facing up and I go right down. Okay, yeah, that's messed up. Let's try that. He starts facing up and I go right down. Okay, yeah. So he somehow snaps to be facing exactly the opposite direction that he should be, right? So I'm going to go right, down. He's going right. And then as soon as he starts the down, he like teleports. And what that means to me, so probably the down animation, it gets that theta base. And for some reason, so here's the thing that I'm not sure about, right? So when we talk about pushing minus signs around. So we do this theta base thing, and we're adding it to well, this part doesn't add it, it just records it.
Yes. So what is that being accumulated? Is the theta base like being accumulated by what the animation tells you to do or something? What's happening there exactly?
Well, okay, this one is a weird one that I don't understand, which is not helping.
Okay.
There's two places that do this. Okay, so one of them is like the regular one. So this is, again, just like if we're playing an animation. No, this is not the regular one. This one is the regular one. This is just where we go when we're playing an animation. It has a bunch of channels. We like tell each channel, give me your bones, right? Separately as a channel, orthogonal to the other channels, and then we mix those together somehow later based on whatever we want to do.
The bones are their money, in fact.
They are their money, right? And so are the worms.
Exactly.
But we don't show the worms here. This is the simplified version that just has the bones. So, anyway, this is the thing that sets this, and this only sets it. Now, this thing down here, maybe I should actually stop for a second and think about this. This is like, what am I doing here? So this gets called every frame when, when we put time into the thing, and we look at each channel. And if it's an animation, in this game right now, there are only animation channels. This was ported from The Witness, where we had IK channels as well, which we might bring back probably. But for now, there's only animation channels, I think.
Yeah.
So we call accumulate time, which again, just like on the channel, right? So this is an overload. This is accumulate time for the whole player, and this is accumulate time for each channel. And again, that just steps to wherever we are between whatever keyframes and interpolates the bones, which are the money for those keyframes, right?
Right.
So now if we're blending out, right, then, we're incrementing some timer, and if we're done blending out, which, this could very well have something to do with it. If we're done blending out, so we're about to disappear, and we control turning, and theta base is not initialized, we set it to 0. I don't understand why I'm doing this at all. There should be a comment here, and I didn't put one, so I'm stupid. If it controls turning, but it's not initialized, that shouldn't really happen.
Yeah, like what was the reason that had to be lazily initialized, I wonder?
Yeah, and
someone thought it had to be.
This might have only been necessary for an earlier version of the code, because like this code down here that uses it, right, that I was just playing with, only cares if that initialized is set, right? So
if you set a breakpoint there, does it ever actually hit? Like, does anyone actually get to that thing, or?
Good question. That's a thing we can ask.
The one in accumulate time, I mean, because if it never gets called, we could just delete it and not care anymore.
Well, let me figure this out. So I'm vaguely remembering what this was for. This was something about what happens. Okay, if you play one animation that controls turning, like, this is probably what the bug is, by the way, because, the bug here only seems to happen when I string together multiple animations that involve turning, right?
Mm-hmm.
And so here, what this is a handoff from one animation that involves turning to another one, right? This is like, okay, if we're blending out, in case somebody else is blending in, okay. Yeah. So the problem here is so the base is the gameplay angle, and here this is this, and we need to minus this if it's mirrored. All we're doing is saying,
yes, exactly.
Like, hey, we're blending out. This is just a safety that says, like, we should have been initialized, and, this probably is unnecessary, but maybe there's some case where you call these on the same frame. I'm going to put a cleanup here, right? But this is the thing, and the problem is the animation player doesn't know if we're mirrored necessarily. So it's trying to do this handoff for continuity of the angle, and it like can't totally. This thing doesn't know about entities like on purpose in order to make it simpler, like quote unquote simpler, which sometimes just makes your life harder.
Hold on a second. I'm still confused. Sorry to ask so many questions.
Yeah.
Instead of rubber ducking, you're basically getting like the Inquisitor duck, which is like the worst kind of duck.
No, that's fine. I mean, like I said, I hate rubber ducking, but if we're doing it, we're doing it in style, man.
So the player turning control theta base. So this is you're actually controlling the direction of the player from the animation, or? Yeah.
Okay. So the animation.
What's going on there? Because that seems weird.
The animation is, of course, like relative, right? So, or this angle is relative. So when we load the animation for like turning to the right, well, let me explain this. Even you'll understand this, Casey, but of course we're explaining for the audience at home. How many viewers do we have?
A lot.
10? Do we have 10? We have 427. Great. 427 people not getting diseases right now. So, originally, in the much earlier version of the game, before there was an animation system and stuff, when you turn to the right, we would just interpolate it in code. Like I was saying before, we would say like, oh, our angle is offset from where we want it to be. Let's linearly interpolate or something, right? In general, animators want to have more control over that. They want to have more style, right?
Gotcha.
You want to be able to make it do whatever. And so we add this option to let the animation control the turning, right? And then the problem with that is that, you know, at the end of the animation or whatever, you need to propagate that value back into gameplay, right? You like, or something, or like I said before, what happens is we look at where it is at the end and then say, does this need to be interpolated further in code? Which hopefully the answer is no, because the whole point was that the turning was controlled by the animation for good style, but you can imagine weird cases where you kill the animation and replace it with another one that doesn't control turning or something, where you end up in the middle and then the gameplay code takes it over. Okay, so what these variables are is the following. Turning control theta base is just, this was the gameplay direction between 0 and 360, or minus 180 and 180 probably actually. This is the direction that the player was facing when we started playing an animation that controls turning, right? And so this is not relative, and we're not actually changing it every frame. The reason being, I guess, for reasons of mathematical error, or maybe we start blending in a new animation or whatever. It's like, look, here's where we started. And then every frame we have an offset. This offset, so we usually don't do this thing that we're doing right here. Usually what we do is we just record the base, and then we modify the offset, which is a relative offset that changes every frame. And then the gameplay code back here says, okay, are we animating something that's using this? If we are, then add the base to the offset, right? And if maybe negate the offset. Okay. So the problem is as follows. The thing that usually initializes this base is when you start playing an animation that controls turning. And we set it from not initialized to initialized. And so the problem is, what happens if you're already initialized because you're playing something that controls turning, and then you switch to another animation that controls turning? Well, you need to record what the theta is, but that theta is not equal to the theta base, because remember, the theta base doesn't update every frame. It should be what the character's current theta is, but this code doesn't know about entities, so it can't look at that, I guess, was the reason why.
So the part that I'm having a little trouble wrapping my head around there.
Yes.
Besides the fact that somebody in the chat thinks that if you did this in Unity that it would go well, because as if mirroring anything in Unity ever works even a little bit, but that we could talk about that later.
Yes.
The thing that I'm a little confused about here is how exactly would, it can't be that the animation is really controlling the angle that the thing is in the gameplay side of things, though, right? Because in the gameplay side of things, you move along 90-degree angles. So it's not like the animation can come in and change it.
Let's just for very basic, right? It's in Entity Manager. So there's actually there's three things that matter here, right? So every entity in the game has this undoable entity data, right? Which has way too much stuff, and we're going to slim it down later. But two of those things are theta current and theta target, right? Which are flat angles in the XY plane. This is ignoring Z rotation, because we don't really have that in gameplay in this game. So theta target is what actually matters for gameplay. This is the thing that gameplay code looks at to determine what is happening, right? Theta current is what is visually on the screen right now. So in general, that will be equal to theta target unless you're transitioning and then it's interpolating toward theta target, right?
Yep.
And then, but of course, because it's rendering, right, we have this up here, this quaternion, which is actually, we turn theta current into a quaternion once per frame by just rotating around the z-axis, right?
Yep.
And that's just to put it into a common language with other things that are not gameplay objects. Like you might have things in the background, like nice bushes or whatever, or whatever, that bricks in a building that you don't want to constrain to this gameplay style constraint of only rotating in the XY plane. So the common language of the game engine, of course, is to use this orientation to talk about how things are rotated visually, right? And so we get there by doing this, right? So all that makes sense, hopefully, to you and the audience at home. There will be a quiz later, audience at home. Okay, so this thing in simulate is the thing that updates theta current. And if we're not using one of these funky animations, we just do this. So first of all, we say wrap theta current, which puts it in like minus 180 to 180. And we know theta target is already in that range. And then I have this move toward function that just like says, you know, make this value closer to this value by this, but clamp it or whatever. This is an interpolation over time, right? So this is what we're doing if we're rotating in code, okay? We end up with...
I totally get it now. Just to make sure I'll restate it. But so the idea behind the way this system is structured is I have two values. One is the value for gameplay, and one is the value for display.
Yes.
And the way I do it is there isn't like a third value or anything, which is where the animation is pointing or something. What we do instead is we still interpolate the orientation towards the target orientation manually, not by animation every frame, but we let the animation tell us that it changed that current value out from under us anytime it wants to, basically.
No. Almost, but no, right?
Okay.
So like this thing that's highlighted is what happens when there's no animation. And maybe the answer is I should refactor this to be simpler, right? We could talk about that. But I'm all for simplification if I can figure out
I see. You don't, right. Okay, so you don't ever do the lerp if the animation took control.
Yes. So basically, okay. So this entire set of if statements here is what happens. Let me delete this no check in here just to clean it up. Okay. So
all right. I think I'm with you. I
lied a little bit. So this thing here is what happens for inanimate objects, right? That don't play animations, right? So like if you've got a light beam in Promised and you rotate it, it does this linear 90-degree rotation, and that's fine. Okay. For things that might have an animator attached, we go up here. And if player theta base is initialized, that means the animation is controlling it. We do something more complicated. Otherwise, well, this is just a paste of this thing down here. Timing is probably off of me talking versus you seeing it on the stream, but
no, I get it.
There's the same two lines that's pasted, right? So we do this same boring thing if the animation is not controlling. If the animation is controlling, the only thing we do different is we say, well, this animation is telling us how far it is rotated relative to the beginning of the animation, right? So the beginning of the animation is 0. As we turn, say we're turning right, it goes from 0 to minus 90 because a right turn is a clockwise turn. So that's negative angles in a right-handed coordinate system. So we do that, and we're just taking this relative offset and adding it to what is our angle at the beginning of when that animation started playing.
Yep.
Right?
Yep.
So that's all fine. And my claim is that this is correct. The part that is wrong is the hack that maintains this value when we transition from one animation that is rotated to one animation that's controlling rotation to another animation that's controlling rotation. That thing does this okay, so the reason this is factored this way, this is one of those things where you want it to be clean and it ends up not being clean. The reason it's factored the way that it is because I kind of don't want the animation system to think about entities or what the gameplay code is doing or anything, right? And so it's like, I'm doing the addition, thank you, just tell me how far the animation has rotated and I do not care and blah, blah, blah. Okay, so the problem is when you switch from one animation to another animation, you're switching from one relative angle to another one that's totally different. Like, say I'm doing 2 right turns in a row, we're going from 0 to minus 90, and then we're instantly gonna pop back to 0 as soon as we switch to the next animation, because that data is baked into the animation, right? And so, of course, we need to integrate that value into our gameplay, right? In some way. And maybe the way to do it is to set some value that says, oh, dude, we totally just reset our theta, so take this value and add it yourself as an external party. But I don't actually do that right now.
Well, so I have another question for you then, while I'm sitting here ruining your entire stream.
Yes. No, I'm sure people are enjoying this because they could probably understand what's going on way better than usual. Because I'm spending all my time explaining these things, people who want
you're getting interrogated. It's like an interview.
Yeah. We can put this up as mock job interview number 2, right?
There you go.
Yes.
So the thing that I was curious about is, why can't the animation system, why does it need this concept of the theta base per se? Can't the animation system just keep a running sum? And then whenever you go look at it, you set it to 0 when you pull the delta out? So in other words, the animation system's just doing plus equals on everything, always, whenever it transitions, and it's just keeping an accumulator. And then anytime someone on the outside decides they want to use that to update the theta current, they just take it and set it to 0 at that time. Why isn't it that way? Because I'm sure there's probably a reason why it's not that way, but I'm not sure I see why.
Well, I mean, at some point, a lot of the time, the reason is it's arbitrary. Like, I thought it would be better some way, and it wasn't, right? Hold on a second.
Yeah.
Let me go back to this one. So I guess what I do, I was trying to factor this apart to the greatest degree possible. Like, I don't want this to know about entities, maybe because I want. So, part of the whole grand plan of this game is that we want to be able to give people the game, right? And then they have a Sokoban game in this new programming language. And, part of the idea, so right now, if you want to be a programmer who understands how games work, you sort of only really have 2 choices most of the time. Well, there's 3 choices. So choice number 1 is suck it up, use Unity or Unreal, and don't ever control how anything else works in the engine, right? Number 2 is go use an open source engine like Godot or something. But it's this huge giant engine that's trying to be general purpose and very complicated. And so if you were going to go try to program on that and learn how things work, it's like going to NASA to figure out how to build something or whatever, right? It's like they're doing something giant and super complicated, and it's like, dude, I just wanted to build a cabinet or whatever, but they're building the space shuttle, right? And I have to figure out how to build the space shuttle in order to build a cabinet or something, right? So that's not really ideal. And then maybe they're building the space shuttle badly and they should have built rockets that could land or whatever, right? Okay.
Yes.
Choice number 3 is you go look at the source code of something really that's probably too simple for you to care about. Like, here's my little dippy 2D game engine that draws sprites that are really ugly, really slow with incorrect alpha masking or whatever, right?
Yes.
And you can learn that way, but that's not that good. And so, I think like projects like Handmade Hero probably help fill this gap to some degree and whatever, but I'm just talking about the general landscape, right?
Yeah.
And so the idea was, okay, let's make something that's a game. And, part of the problem is when people release a programming language, either it's somebody like Bjarne Strostrup, who has never programmed anything non-trivial in the language and just has theories about what would be good.
Or any other language.
Yeah. Or it's a bunch of people designing by committee and just building up tons of code and whatever, right? And so the theory is, let's build something real. So we're vetting the language. We're making sure it works well and actually delivers as promised on a large code base. But then while we're doing that, well, we want to give people examples of how to So this is becoming more and more depths of like the rant or the tangent, but this is all, we're bundling together the full explanation here, right?
Yes.
So
in order to create an apple pie from scratch, John.
Yes, you must. Okay, so the proton, first of all, has a positive charge.
The Earth cooled.
Yes, and then the dinosaurs came. So if anyone in chat understood that movie reference, you're too old. Okay. I mean, I assume that's the joke that you were making. Anyway. So, where was I? Okay. So when
You
you
were going to
design
say
a
why
programming
it
language,
was done that way, yeah.
Okay. So people often ask me like, "Hey man, is there a spec sheet for your programming language, right? Like where's the what do you call it? Just the spec document." And I'm like,
Right.
no, okay, first of all, that would be a big distraction for us to go do that because it's a lot of work that is not being put into the actual language, right? Secondly, the spec's going to change a lot between now and later anyway because you want a lot of freedom to change possibly very fundamental things based on how your prototype of the language interfaces with reality, right? If you're not giving yourself the maximum ability to do that, you're kind of screwing up, right? And then part three is I never want to learn something by reading the spec anyway, unless I already know basically what it is. Like if I'm going to learn a new graphics API, I might look at the spec or whatever, because I've used 17 of those, right? But a programming language that's good, you don't really want necessarily to know just like the syntax or whatever, like, because the ideas, the design decisions that were made in the language, if made by a competent designer, were made to support a certain kind of programming, right? And so you're not just saying like, this is the spec of the language, but like, here's how it's intended to be used, right? These are, if you think certain kinds of things, you know, don't map very well to this language, well, maybe it's because we recommend that you do these things a different way. So for example, somebody who shows up in this programming language and says, how do I translate my C++ code that's full of constructors and exception handling? It's like, well, you don't really do that here, right? You do a different thing.
Yeah.
That's a very obvious example, but that's a multi-scale thing, right? That happens at all scales, right? So as a very simple example, this programming language is a lot about for loops. It's a lot about writing very simple for loops that do a lot. And that's why that certain data structures are set up the way they are and et cetera, right? So that's a thing that you wouldn't necessarily know from reading a spec that says, here is the syntax for the for loop. That doesn't tell you that the language is about leaning heavily on for loops and arrays and whatever, and so on. Okay, so then part of that is, you know, the documentation that I'm trying to get to writing more of, that I haven't actually in a month, is like, hey, here's a sequence of programs in this folder that start very simple and they get more involved, and they just show you what programs in this are like with a lot of comments, right? But then having, you know, those are just samples, right? And so having real software that people could look at that maybe is not the cleanest code in the universe because, like, come on, we're shipping a real game, but is reasonable, and that does things that you care about, that shows you how the language is intended to be used on something real, not on a sample. That's like the missing link that people don't often do, right? Like in a tiny sample, you can make it pretty all you want and like claim that this is how the language works, but like, how does it really work, right? Like, how is it intended to work? How does the way that it's intended to work really meet the way that it actually works in reality, like when the tires are spinning on the road, right? And you're getting somewhere. So I want to provide that, plus also, hey, if you want to understand how games work, well, if the theory is correct that I have, that you can do some things a lot more simply in this language than you could do in other languages without taking all the penalties, the performance penalties that functional language people want you to take and all that for the simplicity that they claim is there, which sometimes is more simple, but sometimes is just sweeping stuff under the rug and pretending it's simple. Anyway, if you actually can make it a little simpler, then that would be a nicer learning environment for people who wanted to pick up a new language, because they don't have to see all this like template metaprogramming garbage, whatever. Or, I mean, of course, you can do something in C or close to C. It's just a different, like, how do we use higher level constructs without it being a frickin' hard to understand mess, right? So that's like the whole thesis here. And so the plan is, well, we'll give people the actual game that we're going to ship, except, of course, because we don't want people in countries where pirating is very easy to just like clone our game and put it on Android or whatever. We're just going to like factor the code so that a lot of the files that are important to the specific gameplay and levels that we are shipping will not be in the public distribution. But what will be there is the full game other than that, right? Like you'll be able to run guys around and push blocks, and it'll have all the graphics and all the sound. And that'll be kind of complicated because driving, you know, modern shader systems is not totally simple if you're not used to it and whatever, but it'll all be, it's a real game that's all going to be there. And it gives people another option, right? Instead of having to put up with Unity or like try to deal with Godot or something, it's like, this is a lot simpler than any of those engines because it's a specific game, right? Just like the engine for Handmade Hero, right? It's like, it's for that game, right? Or probably also, I don't know how much of the decisions that you make there are for the specific game versus like what is easier to stream and teach or what's more informative, but something like that, right? It's like,
well, since I'm not a game designer in general, it's just for like, what would be a difficult thing for the engine to do here? So let me do that. Like supporting very large worlds. It's not really something I needed. It was just like, that's a more interesting thing to teach someone to do than just like, hey, store something and then learn later that all your crap breaks when your world gets larger or whatever, right?
And so you're doing like more than the minimum that you would have to do, but it's still way less work than like if you were trying to make a game engine for anybody in the universe to use, right? First of all, which is like the business model of Unreal and Unity, right? So first of all, it's a much smaller, leaner thing. And secondly, it's a lot easier to understand because it's not trying to do everything in the universe. Like if you try to look in the code for something like that, you don't know what's going on half the time because like everything is super general, you know, and there's just a lot of code and it's been worked on by hundreds of or thousands of programmers and it's super crufty, whatever. Like, so the idea is to be like that, where it's like, look, it's doing one thing, but then if you wanted to understand, like you could definitely delta this engine to a place where you were using it for a first-person shooter if you wanted to. It's just, that would be some interesting work on your part, but you would start in a place that's easily understandable. Like, oh, it's a third-person game. Let me just change the code that sets up the camera or whatever. So the goal would be that people could take it and do whatever they want with it. Maybe they just rip parts of it out and use it or whatever, but it starts in a relatively understandable place. So that pops us up several levels of the stack of explanation. And so then we get back to, I guess, that's kind of why the animation system is a little bit more factored apart than it would normally be. Like in The Witness, I didn't care about the animation system not knowing about entities. It's just like, whatever, dude, like everything talks to everything else because we're making a specific game and that's what we're shipping and who cares, right? And like, and in fact, I'm a little bit contemptuous. Contemptuous is the wrong word because it implies more emotion than I have at this point for this. But the thing that they teach people in academia about like, well, and even in industry about like always just super factor everything apart so that nothing knows about anything else. That's very destructive to code because, well, nothing knows about anything else. And it just makes your job a lot harder. It makes you do a lot more busy work. And it just makes it harder for people to understand. This is the thing that people don't get who are teaching this stuff is abstraction makes things harder to, even if it's perfect, which it never is, it always introduces inefficiencies. It always makes your code bigger and slower. Even if it didn't do any of those things, it actually just makes your code harder to understand because you don't know the context of what's happening anymore because general things are less specific than concrete specific things, right? So like if a function loads, let's go back to this animation file, right? This is a very simple format. It's like, oh, if a line starts with a hash, it starts with a version, right? Then if a line starts with a hash, it's a comment. Then if a line starts with a colon, whatever, right? And then it's got some commands, right? The code to parse this is very straightforward. It's a couple hundred lines. You see the, oh, parse out the first word of the line. Is it the word animation? Is it the word looping? Like it's very easy to understand, right? What you would get taught in an advanced computer science class in school or whatever is like, no, you want to write a grammar for this thing. And then You want it to be parsed by an engine that not only parses that grammar, but like other grammars and stuff. And it's like, okay, first of all, if you wanted to debug why something wasn't quite loading correctly, by the time you're in the middle of like that system, you don't know what's going on because that code doesn't know what's going on. Because the code to parse the general grammar doesn't know anything about your specific file format, right? And it's just very difficult to both for the code to get fixed, right, and for you to understand how to fix it, like when you're going in there, right? So that's a general phenomenon that I wish people understood more clearly. I don't know.
I'm 100% with you on that one.
It feels like a little bit more of a side rant. I don't remember now. I'm trying to connect that back to talking about the animation player, and I don't remember. Oh, well, it's just to say that I don't, like in my own code, if I'm not planning to distribute it in this way, this code would just know all about the entity and probably just yank the value off the entity. But I'm trying to introduce a little bit of a separation. And this is very instructive because we're just trying to have a little bit more abstraction about this one value, about how much is someone turning, and it's already making something more complicated to think about, right? Like if I had the entity in here, I could just say during this handover that I'm saying is buggy, which is, this is the other place, right? This one.
Right. So but,
this thing
okay,
could just look at the entity and say, okay, like
I'm not even asking that though. I'm sorry if I implied that I was asking why.
I just talked for like half an hour in response to your question, and I don't remember exactly what the question was.
Yes, which was all good actually for people to hear. So like, I'm glad I provoked it. But
so to summarize, one last sentence. I'm trying to keep this a little bit cleaner so that somebody who wants to turn this into, maybe they like Unity style entity component system or whatever, and they don't even have an entity struct, and the entity is a bunch of arrays of data, which is not how it is in this engine, right? They could then grab this animation player and still use it without ripping it up that much, and they could use the file formats and all that. So, I'm not going all the way to the steps of, like if I was making Granny, I would put in a huge amount of work to try to generalize this, right? This is not that. Granny, by the way, is an animation API that does a whole bunch of things that Rad Game Tools made that Casey knows something about. This is not that, but it's just sort of taking the minimum steps to like not obviously make you have to do a bunch of crap if you want to use this. You're probably still going to have to do some stuff, but it's just not going to be as ugly, right? And trying to prevent from the thing that happens over time where it gets uglier and you're forcing people to cut it apart again too much. So I'm just trying to keep it just a little bit clean.
Yes.
Yes.
So again, very glad I provoked that. However, I was actually asking a much more timid question than the one that I think you thought I was asking.
Well,
what I was asking.
Go ahead.
What I was asking was simply, there's two ways that this system can work, and I was simply asking why it worked this way and not the other way for the same API decision. So not suggesting that it should be more or less abstract, not suggesting anything like that, because the last thing I would ever do is suggest to someone that their code base should have a harder wall in it, because I hate those things and it drives me insane. So I'm actually 100% with you on any of that. But I meant to...
If I'm going to anticipate your question, tell me if this is correct, because I think I understand the question.
Yeah.
It's like,
okay,
why doesn't the animation system just add deltas to the angle every frame, and then you just look at that to see what angle the guy should be at? Like, why is it not that way? Instead of
more or less, that's my question. But just to be more specific about why I even have that question is because it seems like the way that it's being done currently requires you to manage this secondary parameter, which is the basis off of which the animation is reporting things.
Yeah.
And at the moment, that basis has to now be like exported out to the code that you do have the API wall across, and it doesn't necessarily know like what was positive or negative and vice versa. And
Totally.
so I was just thinking, like, could we just keep exactly the same structure of the code, but remove that theta base is really, because if we could, then maybe this code gets simpler and then the negation bug goes away, right? That was my question.
Yes. So, and in fact, I think the solution ultimately, no matter which way it happens, is going to be, so if I was going to do it that way, let's say we pass in every frame or whatever, the player's current angle, and then this thing records it when it wants to, and then adds deltas. I'll explain in a minute why I probably didn't do that. I didn't leave a comment, so I don't exactly remember, but I could guess, right? If we did it that way, we would have to negate that angle in here, right? Because we're flipping the animation data. So we would have to have a parameter maybe on the player, or maybe just to this function that says like, we're mirroring the guy. Like it would be a flag that you pass in, right? And I
Wait, but why? That's the part that I'm missing, because it's like what I was thinking we could do here is just player.turning control theta base just goes away, and instead what we do is we just have player.theta accumulated from animation, and it just always gets added to, no negation. And then the outside code just periodically picks up that delta and sets it to 0.
Yeah. So probably the main reason I did that was to be paranoid about numerical error and consistent results. Like, we don't really do this anymore. Like, I don't think there's anything that cares about exactly how many frames it takes for the interpolation to reach the target or anything, because like no gameplay switches on that right now. But that used to be a thing because, you know, early on I didn't totally know how it was going to go and whatever. So I was probably being a little paranoid and being like, well, if you want this to run at different frame rates, it should take exactly the same number of frames, right? And so, you know, in rare cases, minor differences, like if the value stored in the animation okay, let's step back for a second. The value stored in the animation right now is each frame contains the value of the angle relative to the angle in the first frame, right? If you were to pick that sample exactly, of course we aren't usually picking one sample within the animation exactly because we're not Quake 1. I guess they fixed that in Quake 1 now, like the fan re-releases. But Quake 1 originally would just like pick at 11 FPS or whatever it was, like a frame of each guy. We're not doing that, right? We're interpolating smoothly with the bones moving because the bones are their money. So
yes.
So what we do is we figure out what time is it, which two keyframes are that between, and so take the angle for the starting frame and the angle for the ending frame, and then interpolate between those, and that gives us an angle relative to the beginning at which we currently are. Now we could do that differently. We could instead in each frame store the angle relative to the previous frame instead of the angle relative to the beginning, right? And then you could say, well, how far am I into the frame as a parameter between 0 and 1, and just multiply the value at the end of the frame by that, and that gives us our relative offset. Well, except you would also have to figure out the value from the beginning. Like, it's not just how far you are, it's like where you started and where you ended, and then subtracting that. And that might get a little complicated because when you cross a boundary, like right now, if I cross a boundary between frames, I don't care. I just say like, where am I in the final one, right? And if you were actually recording deltas, you would have to like record the remainder and then, you know, add a little bit from the next one. I don't know if that would be any more or less complicated, but it would definitely be a thing that would have to happen.
But I guess, so again, like the part about this that I guess escapes me a little bit is just that, but you do have the turning control theta base in here. So it's basically currently having to sort of just update that. I guess so. I've turned
I
45
agree.
degrees.
It shouldn't really be in here. Like that's what's messing this up is the fact that this really is this really is something that the animation system shouldn't care that much about. But it does. So if I wanted to do it the way that you're suggesting, the cleanest way for this system would be delete turning control theta base completely because that's weird, right? And like you said, this thing, I mean, I guess it could have an accumulator.
Can you switch back to the other function, the function that's actually picking up this value and using it on the outside?
We'll put both of them up through the power of Emacs, the awesome editor. They are both on the screen. So like this part on the left is the part that usually, they're both very simple. Oh, wait. So the problem is that...
Yeah, so let me just interject one more thing here just to continue being a horrible influence on the stream. So
I think people are enjoying it, so it's fine.
Okay. So one of the other things, like this is just comes from, again, mostly a fear-based perspective. I mean, it's coronavirus, all right? So like, it's fine.
Yeah.
I remember also like when we were doing this sort of stuff in the past, so like on Granny, when I was implementing the root motion stuff for that, one of the things that I found had to generally be true is that you always kind of had to know the instantaneous state of things, because otherwise, no matter what you did, you could never really fix problems that would happen when you wanted to like instantaneously blend between two things like that were right in the middle of random parts of their loops, right? So originally when I did it, I'd had stuff in there that was trying to do sort of like a overall like motion separation between the root motion and the other bones that would keep the root motion as just a straight like linear interpolation to make it like easier on the engine developers or something, right? And the problems that I kept coming into was like people want to interrupt things or do things in the middle. And so I found that basically I just always had to end up regressing to code which like always knows the instantaneous actual state of things. Yeah. And so whenever I see something like theta current equals player.turning control theta base plus theta sign times player turn, I'm just like, that's going to be a bug. I don't know why yet, but I'm sure it will be. And so that's why I was saying, like, I agree with the numerical precision part, which is to say that you can't just accumulate those values and expect them to line up to something correct at the end of the day. But if you do actually do stuff where you're like, okay, while there's no animation that's controlling the turn, I do an interpolation towards the target theta, that should clean up the failures, right? I would think.
Yes. And it is doing that.
And so, yeah. And so, so to me, it's like, well, yeah, that just makes me want to get rid of the closed form evaluation that goes over multiple frames rather than something that just accumulates deltas over time. And that's like where my head's at, just to give you some idea of why I'm scared.
That's kind of reasonable. And, again, this is one of these things where decisions made for various reasons, like, God, I'm scared to say this number, but like almost 3 years ago, when I started this, or maybe even more. I might have started this in 2016. I mean, it was a 2D game in 2016, so this stuff wasn't there. It was probably a couple years ago. Anyway.
It's not a long time to develop a language and a game, by the way.
Yeah, no, I know, but like, oh my God, dude. Time goes by so fast.
And run a company.
Yeah. Anyway. Yes, so sometimes whatever reasons that I had are no longer relevant, even if that was the correct decision. Sometimes it just wasn't the correct decision, even given those original parameters, if they're still true, right? And like, I work on so many things now, I don't remember which of those is the case. So I am perfectly happy to, for example, like I agree that it would be cleaner to switch this to just an accumulator, right? Where values just go out and you pick them up if you want. Right. And then this thing can pick them up every frame and add them. And if there's a little bit of error, no harm, no foul, because we don't care. Right. I'm totally fine with that decision at this point. The question that I then have is what's the best way to make it an accumulator? Because we still have a little bit of this thing where, um, um, so there's already an implicitly weird thing happening when we play animations where we'll be playing two of them and both of them may be trying to control turning and one of them is blending out into the other one, right? And so like what happens there? I think I just pick the first one or something. Maybe that's not right.
Well, one of the nice parts about
no, hold on. I'm looking at the same thing. Hold on. Yes. So like for every channel that controls turning, well, again, this is a numerical error thing here that hopefully the stream is caught up. It's like, oh, if I'm the first guy turning, I just set the total offset to be mine, right? Or if I'm a later animation who also wants to turn, we add that, which like doesn't strike me as being correct because there's
I don't think it is.
So like that's effed up, right? So maybe you need to take the delta and then multiply the delta by the blend factor. Or whatever.
That's what I was going to say is the accumulator, switching to an accumulator lets you get the correct answer for n-way blends as well, which you wouldn't get with this. So that seems like another good like thumbs up in favor of making that change. But
that's not really something I have test data for at this time. So it's like not exactly something, but you know, to at least try to make it right. And then we could add some test data later. You know, the reason this doesn't blow up is just because we only ever play one thing probably that.
And it's also, it's more for just like, oh, hey, to prevent future bugs or something. Because yeah, it's like you'd have to be doing something fairly specific to ever see it anyway. And it's also a bug you could probably just live with because since you have the cleanup in there, when the animations stop, it won't ever actually screw it up, right? It'll just look a little wrong.
I wonder if this is causing really weird problems. Okay, I think the real reason that this doesn't cause that much of a problem in reality right now, I think we do play. So like if I'm turning to the right and I blend in some other animation that has me turning to the right, but like, I don't know, let's say turning to the right and falling, which is not actually a thing, but just assume for a minute that that's a thing. I think the real reason this doesn't cause problems is because all these animations happen to start at 0 relative angle and go up, right? And so if I add another one that's also turning us, but we're also blending, like the amount extra that gets added is going to be small in the beginning because we're just starting at 0 and counting up. And then by the time we get relatively high, the other one has probably blended out because the blend times are short. But this might have led to the animator doing weird stuff like trimming blend times to be really short.
Yep.
Because if he doesn't do that, wacky things happen and he doesn't understand why, right?
Yep.
Okay, I am getting cold, so I'm going to warm up some more tea and grab some more chocolate, and then we'll maybe do this. Why don't you feel free to talk to the fine audience out there while I'm doing that and tell them all about whatever is important in life.
Because they say that my voice is too loud, probably despite the fact that it's normally very loud, because the desktop volume is probably too high or something in OBS. Let me check
that. I mean, it does sound a little bit like blown out to me. Talk again, say something.
Hello, I am the voice.
So I have turned that down by minus 12 decibels now. And because people who are silly are in charge of audio, I still, to this day, don't know how much minus 12 decibels is, and nobody does. No human being on the planet Earth knows what that means. And this is one of my pet peeves that I haven't ranted about in a long time. But anytime you'll go read some tutorial about something, right, about how to learn this particular subject, they start with the same freaking like 5-minute decibel tutorial, like every time. And I'm like, dude, if instead of decibels, you said 10 to the minus 2, everybody would understand and it would be fine. But no, you have to use your weird medieval units that nobody knows what the hell they are. And then, of course, there's not just decibels.
It's so unintuitive. It's like the least intuitive thing. Like it's similar to the Richter scale. It's like this is not good for humans. They
No.
don't get it.
But the worst thing is there's two different decibels, right? There's like relative decibels and absolute decibels, which is also like a thing.
Right.
Like,
Yes.
what the hell is that all about? Just like
I don't know. I
pack
never
it up.
understand any of those things.
Stop it and use actual numbers that people understand, and it'll all be better.
It's terrible. Absolutely terrible.
Yes. Okay. So I'm gonna be gone for about a minute. You have the con, as they say in Star Trek.
Okay. Understood. So I have to talk about something, but I can't actually do anything on the screen. So that actually does make it somewhat difficult. However, I suppose it's fine. No, now I'm too quiet. All right. No one's ever satisfied. I'm too loud. I'm too quiet. Here, let me see. Where's the actual?
I'll turn it up again. I'll turn it up from negative 12 decibels to negative 7.8.
No, it won't matter
decibels.
because people will just. Some people will complain it's too loud, and some people will complain it's too quiet. It's volume. No one can agree on this. So yeah, like basically the thing that John's doing right now it's a huge problem everywhere. Like this is something that like until you've written animation systems, and even after you've written animations, because John has, it's never really clear like how you solve the root animation problem. And like there's always going to be code that exists like this that's just like really annoying, and you have to kind of like work through how you're going to make it work somehow for your particular game, because it never works cleanly. Maybe like if I did a third version of Granny someday, like I would try to actually sit down and really figure it out this time, but it's just one of those things that's like it doesn't come easily even if you know what you're doing. And so to sort of explain what's going on in a broader sense, the problem that you're fundamentally trying to solve is that when an animator creates animations, such as like in Maya or something like this, or any kind of content creation package, so the animator makes something nice, right? Fundamentally speaking, they are not actually animating anything that appears in your game. What they're animating is like a core building block that will then appear as some processed thing in the game, right? So they do something like, okay, we need the character to be able to turn 90 degrees to the left because that's something that happens in this game. So they make an animation of the guy turning 30 degrees to the left, or 90 degrees to the left, right? Export this thing, and now you have a data file with a bunch of animation tracks of the things that the bones in this character would have to do to turn 90 degrees to the left. And it's very easy, actually, once you're fairly skilled at these kinds of pieces of code, like John is, or like I am after having done the animation system at RAD. It's very easy to figure out how to get that to work, right? Like it might take a few days of you writing out this code, but like I'm just going to go ahead and guess that John probably didn't have to spend a huge amount of time getting like bone-based animation working. He probably had to like clean out some cobwebs in his head from the last time he did it, but then he probably like just got it working and like was able to debug it after a while, and it was like fine, right? And the reason for that is because bone-based animation is a fairly direct translation from what's happening in Maya to what's happening in the actual game. And the only problem that you're likely to have when you're debugging it is like, oh, I accidentally like did something where I like forgot that this thing was in like the parent space when I saved it, and now I'm not doing it in the parent space now. So space, like remembering which spaces, like what's in which space and what's relative to what, that definitely happens. And I didn't see John's like streams where he implemented this, but like there's probably some bugs like that, and you work them out. But eventually it's fine because fundamentally speaking, again, it's very close to what's actually happening in Maya. So you play it back, and it's what you'd expect. But now comes the hard part. And the hard part is that animation just does literally what it says. It takes someone facing in a particular direction that the artist modeled it, right? And it turns it 90 degrees from there. And that's it. That's what it does when you play it back, period. And that's all it's ever going to do when you play it back. So somehow you have to make the link from that playback of the animation, which is what you literally have, to something which can effectively provide the ability to turn 90 degrees from any particular point, and furthermore, stop possibly partway through that 90-degree turn because the player decides to do something else, like turn back the other way, right? And that means there's now this sort of phantom additional quantity that was never considered by the animator in Maya and that doesn't exist anywhere except once you actually get to the game. And that is, what is the technical gameplay facing direction of this character, right? There's now this extra thing we have, right? Which is like a gameplay thing. It's not part of the animation. It's this separate concept, which is which way is the character facing? And this matters for a lot of reasons. One, it's like when this character needs to actually, go in a particular direction or shoot something or whatever, we have a gameplay idea of what that means. Like it has to line up with like the analog stick the player's pressing, or it has to do something that has a semantic meaning. And so you're left with this problem of how do I keep that value in sync with what the animation is actually playing? And there's a couple different ways that this gets done, and they go in varying levels of complexity. And John's trying to do like a fairly complex version of one because he doesn't want to do the thing which I'm about to say, which is the first way people do this that's horrible. And that is like the Prince of Persia way. And that's that you just play the animation and the user literally cannot interact with it until it's done, right? So if you have an animation that's like the character is going to turn 90 degrees to the left, then what happens is the user like hits the turn button, right? They're like, I'm going to turn now. And they have to sit there and wait while the character turns all 90 degrees, and then they can do like their next piece of input. And this makes the problem really simple, right? Because it means that you don't have to think about how to synchronize these things. You just know that it's at 0 and then it's at 90 later. And since the user can't do anything in between anyway, you don't have to worry about what it means to have an in-between there, right? And so this is actually, there's still tons of games that ship today with that, and they feel terrible to play, right? It's always annoying when you're like trying to do something and you're mashing some buttons, and the thing's like, no, I can't do that yet because I'm still in the middle of like my jump animation, right? And so if you want to start breaking away from that, you have to get into what John's doing now. And what John's doing now is having it's sort of like, to continue with John's car example or metaphor where he was saying about, the wheels on the thing and driving around and whatever. Here, it's kind of like a differential in a car, right? You've got two mechanical systems and they need to interface with each other. And that part in between there has to have some well-oiled machinery to make it so that both the gameplay code, which has an idea about which way this character is facing for semantic reasons, and the animation code, which needs to know which way the character is facing for basic presentation reasons, have to have ways of reconciling themselves with each other. Okay, so there's a number of ways you can do this. And the way that John's doing it at the moment is, I guess, for lack of a better term, I would call the animation dominant version. So the animation dominant version is where the animation system basically kicks back to the gameplay code how much turning there is going to be for any particular frame of the animation. So as you're playing this animation or set of animations that are blending, it keeps telling the gameplay code continuously throughout that turn where it thinks the new direction that it's heading is. And this works because if at some particular point the gameplay code needs to interrupt that animation, it still knows what that value is, and so it can do a logical thing there, right? And so if you imagine this in some other game that was maybe a little more action-oriented, because John's got slightly easier, well, it's not really much easier, but it's slightly easier in the fact that his gameplay code at least has specific cardinal directions in mind. But even then, it's really not that much easier. But point being, you could imagine a complete action version of this game where it has to be able to jump in that direction and so on afterwards. So it can now take action based on these intermediate directions and interrupt the playing of the animations at any time by blending in new animations or just doing things procedurally or anything else it wants to do, right? And so this is sort of a scheme where basically the animation drives the gameplay direction, and you just let that feed forward out. And when the gameplay wants to do something, it plays different animations, right? So it tries to play animations that will get it to be doing the right thing. And usually there's some cleanup in here, and that's exactly what's going on in John's code as well, because at some point you typically want to snap it back to something reasonable. So usually, much like in John's code, there's that else case where it would say, like, look, if no animation is controlling the turn, I'm just going to like sort of interpolate it over to what I think it should be, just to keep it right, just to keep it in line with my eventual expectation, right? So that's one way of doing it. The other way of doing it is the reverse. And this way is a lot weirder. And I wouldn't necessarily say that it's, I mean, I think it ships in some things. Rock Band, I want to say, is one example, amusingly enough, even though you don't directly control a character in that, they do try to sync it up with when you like hit the drums and all that stuff. And that's basically a reversal of this scheme. So the reversal of this scheme is when you say, okay, what's going to happen is the gameplay is going to drive the animation. So I'm always going to be feeding forward what I want the thing to be, and then the animation system's just going to try and hit that target as well as it can. And so in this system, what that would look like is, rather than John's code feeding that delta forward, the gameplay code would just say, this is what your orientation is supposed to be now, and the animation system would just be, I will try to like have the animations chase as well as they can to hit that, right? And the downside of that kind of system is that you're always kind of a little laggy on the animation side, because it's going to have all these like sort of catch-ups that happen there, right? And if the gameplay code is just doing things too fast or changing too quickly, and the animation, doesn't have a way to really find an animation that does that, it's going to kind of fail and be obviously wrong, right? So you can see that there's trade-offs in these two different systems. John is back now, and so I feel like I don't have to keep talking.
Well, I mean, if you're not done, please continue. It sounds like
I think that was everything I think I had to say. It was very good timing.
Okay. Well, so I think, if I'm going to fix this problem, so I don't think that I want to change the value baked into the animation, right? That would be silly. That would be overkill. And I think I like having the value inside the animation being relative to the first frame, because, that's just fine. So if I wanted to change this code, I don't know, that doesn't matter. If I wanted to change this code to just output a delta, an accumulated value that we then copy off in 0, I feel like there still is, it depends on how general we're trying to be, right? Like, if I wanted to start playing one of these turn right animations halfway through and have it only turn me half as much, that would be sort of one solution, right? But like, actually, if I were to use like foot matching to blend part of the way into that animation, I actually, for this game, actually want all of the turn anyway, right? Because we want to end facing to the right. I don't know why, like, hopefully we don't really have footstep blending turned on for those, but I could imagine that happening, and it wouldn't be good for this game. Actually, we probably do, come to think of it. Anyway, I'm just trying to think about what's the most expedient and cleanest way to do this. And there's sort of two problems, like I said. So one is just what's the cleanest way to just generate an accumulator, right? And then the second one is this sort of what if multiple animations are trying to control the turning. Now, either way, this multiple animations controlling the turning is not that hard either way, right? So if it stays a value that's like global to the, I don't know how to term it, right? But there's one that's like every frame is a relative delta stored in the animation, and there's one that's every frame is like itself the integrated sum of the amount of turning. It's, the offset relative to the start, right? Either one of those is different. So if it's just a relative angle that we've accumulated per frame already, then we can just, down later where we have the blend values per channel, we would just accumulate each of these times its blend value, right? So if our
Yes,
blend is less than
exactly.
1, whatever. Now,
Yes.
if it's not, if it's like a global angle, we would sort of interpolate according to the blend value instead of accumulate according to the blend value. However, that seems like an inherently ill-formed idea, right? Because who's to say that these are two versions of the same motion, even like you
So
know
usually, like the straightforward solution here, if you can do it, and I don't know what your animation system looks like, but usually all you do is you know the time that you're coming from. So you know like t minus 1, and you know
yeah,
the time that you're going to, so you know t. So you
yeah,
usually just sample that channel at t minus 1 and t. That gives you the two things to difference. You difference them and you get a delta. You just sum those deltas with their blend weights, and that's
yeah.
your accumulator.
Yeah, that's what I was about to suggest. Like
Yeah.
this layer of the animation, this is like the thing that looks at all the channels together. And I think by the time we get there, it just wants to be deltas already, right?
Yeah.
I think. So let's just start breaking things again. So like we're just going to get rid of this theta base stuff, and we're going to have turning accumulator, right? And that's going to start as 0. Although, did I just delete the thing that says whether, like we definitely want to know maybe whether this should be active or not right now. I'm going to leave a Boolean for that. Turning accumulator active. I can't type. Right, and then turning accumulator is going to be 0. And we get rid of this other stuff.
In theory, you probably wouldn't need the active, at least eventually, because it could just always put the accumulator
It
in
could
there and
just
you
be
can
0.
use it or not.
Yeah, I'm sort of going back and forth in my head right now about whether I want the simplest thing, which is just the accumulator, which is 0, or do I want to have like the extra check that I can do assertions on and stuff. And I don't know. I'm going to leave the Boolean there, but I'm not sure if I'm actually going to use it.
Sure.
And if I don't use it, we'll delete it,
Yeah.
right? So, turning accumulator active, right? So then we'll set that, whoops. Like, I can't even correctly, I don't know what, sometimes I just want to copy stuff in Emacs and like, put it in the paste buffer and like, I don't know. That's probably user error, but it comes from me being so fed up with this damn thing. Okay. Okay, so we're not going to have that theta base. This theta base channel is also like ill-formed, I think. I think that was for debugging purposes. Like I doubt that anybody in the universe uses this because it doesn't really make sense if we're saying, this is sort of like what channel is recorded the base. Yeah, and so if we don't have a base, we don't need that. So that's gone. Okay, so if the accumulator was not active and it becomes active, we're just going to set it to 0, because why not? And again, this may not be necessary because we could be saying, look, it's the external guy's job to pull this every frame and 0 it. So it should be 0 anyway, and maybe we'll do that. Let me see how it turns out. So this thing now doesn't really make sense. This num turners is gone. This can go. And then this thing here, that doesn't have to be a per channel thing. That's just like global. So that's automatically a lot simpler. This now makes, it's just a lot easier to just like, what's going on here? Oh, well, if you're not familiar with the language, you're not going to know what this is and stuff, but whatever. Very, very much simpler loop. Okay, this num turners. I don't know why I set it to initialize as true and then back to false. That's weird. Dude, sometimes I don't even, oh, that's just, okay. If we were initialized, but we did the loop and nobody said they were controlling turning anymore, we set it back to false, which means I am using num turners still. You know what? We're going to get rid of the Boolean. We're getting rid of the Boolean. Oh, and this, actually, I couldn't factor this out because that's if a channel controls turning. Okay, we're getting rid of the Boolean. We're just doing turning accumulator because we were going to have to put in a little more infrastructure to set and reset the Boolean than I wanted to. And it's much more likely to have a bug in that than to have a bug in an accumulator, which is a very simple thing. Okay. So, well, now what we were saying is we sort of want to add, so here's where we have this blend factor that we figure out. It's a little bit of an ad hoc blend factor, but whatever. Okay, so I could do it, I could sum into the accumulator here because I just have the blend factor handy. Let me look further down if there's a different place to do it. We also, there's like several phases to this animation blend. It might be more complicated than it needs to be. I don't know. Okay, so we go over all the channels. We're figuring out the blend factors. We're figuring out the target states.
Yeah, I mean, assuming that you have stuff like per bone channel masking and stuff like that, you're going to have more complicated stuff happening, but presumably we just need the one blend factor that's the global for that particular animation should be fine, right?
No, we don't actually do that right now, but what we do, though, is it's kind of a little bit wasteful where, you know, we compute everything relative. I guess I made it less wasteful, actually. I went back like 6 months ago or something. But, you know, to blend things, they kind of need to be relative. So we have them relative and we kind of blend. You know, if it's the first one, it's just that's the value, right? Otherwise, we just blend by whatever the blend factor is, which, by the way, is not an order independent blend, as Casey knows, and may not be the best blend function. Like you might want something like if you were trying to blend between three different poses and sort of have a triangle of possibility space between those poses, this would not be the good blend for that. But that is not what this is intended for.
Right.
This is intended for like one animation is fading out and another one is fading in, like walk to run or something like that, right? And so this blend is meant to be like the next thing in the list supersedes the previous thing in the list. It's not generating an in between that can be between multiple things. I don't know how much better to explain it. Anyway, it's still not, you know, it might do well to think harder about what to do here, but that is not our problem right now. This is, however, the thing that interpolates. This is like where the interpolating for different channels happens. So maybe I should do the accumulator down here, except that this is the inner loop. This is the outer loop for each. Like you basically want to say, hey, channel, what's your accumulator? Multiply it by the blend factor and add it to our accumulator. And that's a very simple thing. And I honestly don't think it matters where I do it. So down here is
this one is a little bit jankier though, right? Because it requires doing a differencing, which the rest of the stuff doesn't require.
Does it for the accumulators?
Yeah, right. Because I mean, correct me if I'm wrong, but you've got stored a channel, right? That's like here's the absolute rotation of this thing.
Oh well,
and what you need to do it.
Yeah, I was just going to put that somewhere else. I was going to put that somewhere else. So, you know, we update each channel individually and then we just look at the channels from here. And I was going to have the individual channel update compute that delta, right? And then this was just going to look at the delta. So yeah, I was just going to sweep it under the rug and I was going to say that there's a delta here. So let me just do it here because this is where we have the blend factor. So apply deltas if this channel controls animation. This is a stupid, whenever I write a comment before I do it and I'm streaming, because my brain is turned off when I'm streaming, the comment is stupid and I'll end up deleting it. So we have this controls turning, right? So if the channel controls turning, then we want to add to the accumulator, and what was it called? So turning accumulator plus equals something, channel dot turning accumulator times blend factor. Very simple, right? That seems better to me. It still doesn't seem totally right, because you're gonna over accumulate in this case, I guess. No, maybe not.
Why would you over accumulate?
Well, because so the way this blend factor works, right, is it's 1 as long as you're the main animation, right? And then as soon as somebody gets added into the list after you, you start fading out. So it becomes a number less than 1, right? So let's say we switch animations 3 or 4 times in one frame because we're very bad about what we're doing, right? Like our code is a mess and it does a whole bunch of different transitions. Games end up doing this all the time. So it's a realistic scenario. So I've got a bunch of animations and their blend factors are like, 0.9, 0.9, 0.91. The first 3 are fading out.
You know
what I'm saying?
I see. Yeah. But you can just sum the thing using the same lerp that you were doing before and then accumulate at the end.
So I would have a constant that says this is how much we're turning, and that would use the same lerp. Yeah, that's. I thought about doing that, and then for some reason I thought about doing this because I was like, oh, the values are small, so it won't matter. But it's better to do that. Yes. So.
Yeah, because you just want these to go through the exact same function everything else goes through. So if that's all going through a piecemeal lerp, then you got to piecemeal lerp this thing too.
Yeah. You'll notice I do all sorts of things like, for ostensible accuracy purposes or something, or maybe just to avoid some computation. Like here, if the blend factor is 1, I just don't do the lerp and like, is that worth the branch? Probably not. But like, I don't know. So, but then it's annoying because now when I add this thing, I have to add it here and here and here, right?
Why would that make it any more numerically accurate though?
Because I don't know, my lerp is doing something, right? It's
because
doing
multiplying by 1 and multiplying by 0 never have any error, right? I don't think.
Well, it's going to subtract one of these from the other, multiply that by 1, and then add it back, right?
So it doesn't do like A B plus C.
Oh no, it might do that. I don't know.
Okay.
Whatever. Right. It might do that.
Yeah. Yep.
Anyway.
Yep.
Wow, this is a really good. I bought some survival ramen, and this is vegan tortilla soup with baked chips, and it's better than it sounds. It's not the best, but it's better than it sounds.
I feel like there needs to be more like MRE, like that MRE review guy is awesome, but there needs to be like 30 of those channels now for coronavirus because everyone needs to know like what to stock.
So right? Casey, I can do an MRE channel. I have MREs in-house, which is why I was watching those videos. Yeah,
you should totally do that, and I will watch that.
They will not be from World War II, but...
hey, man.
Yeah, there's fake news in chat. Slurp does not mean smooth lerp, unless by smooth you mean on a circle.
It says smooth lerp.
Someone said smooth lerp. Yeah.
I like smooth lerp.
Okay.
That lerp is smooth.
So I bought MREs and then, I don't want to incriminate myself in case I put this on YouTube, but I didn't know it was illegal for people to sell them, but apparently it is.
Oh, wait, it is?
That's what I read on the internet. So it's probably true. But then you can buy them on Amazon. So like, I don't know what the deal is. I don't know why Amazon lets you sell them if it's.
It must be like an unenforced law or something.
Yeah. Hopefully it's not legal. Hopefully it's not illegal to buy them. like, or
Yeah,
to
or possess them. Like
or I'm
the
busted.
police are going to come raid your house.
But then they would have raided Steve. So, whatever.
But isn't he like a Marine or something?
Yeah.
So he would totally get
I
out
guess
of
it
it.
depends if he's still a Marine or if he's like an ex-Marine, right? Because
No, but with his Marine training, he can like outsmart them and
Oh,
stuff.
I see. Yeah. Okay. So I'm gonna have some variable that's like amount to turn, right? And that's just gonna equal something in each of these cases, right? In two of those cases, it's going to be a hard set. In the third one, it's going to be a lerp. And then I'm going to say turning accumulator plus equals amount to turn. I could just put this in here. Oh, wait, no, because this is outside. No. Okay, damn it. This is annoying and stupid, right? I want it to be the same function, so I was putting it next to this other thing, but that's wrong. This is like the inner loop that goes to every bone, and we don't want this for every bone. It's just once. So like, we want it way out here. If channel dot controls turning, then, and then this thing is down here. See, I was doing it wrong. So if channel controls turning, if it's the first one, and we're gonna say less than 0 is nobody has done anything yet, right? So if amount to turn is less than 0, amount to turn equals channel dot what are we calling these? Turning accumulator or relative, I don't know. Turning amount, I've got a lot of different names flying around. Okay, right? Else amount to turn equals lerp amount to turn channel dot turning amount blend factor. Yes, I guess that's right. The way that I do the blend factors always frickin' confuses me.
I have a suggestion for that if you want to hear it, even though it's probably not something you want to do now.
Let's talk about that later because I don't need more to think about right now.
Yep, fair.
But yeah, the way that I'm doing it is I've just thought that it wasn't good like the whole time, and not even the fact that it's a straightforward linear blend like that, which is one thing about it, but I don't remember what my objection is now to it. There's something about it that's really awkward and unnatural about starting it at 1 and bringing it towards 0, but visiting that channel first. It's like it's just a little bit weird. Okay. Anyway, so amount to turn is less than 0. We set, otherwise we lerp, and that's fine. And then we add that. Only almost made a bug. Only if it's greater than or equal to 0. Okay. So let's call this like turning delta. So this is going to be computed in the channel, and channel turning amount to turn here is -1. So that is that. This is taking forever to do such a simple thing, but it's part of what happens when you talk through it while you do it. Okay, so we haven't actually done this yet. And this, I'm not sure how I want to do because it's kind of ugly either way. Let's make the variable.
The variable.
Oh, not the variable, though.
Oh. I was getting excited there.
We're going to make a variable. I don't know how to make the variable. Okay, so we already have this controls turning. We have this turning control theta offset, which I guess is just that. Yeah, that's just our value coming out of the animation, right? And so we want to turn that into a delta. And that's annoying because you can't just do like the addition thing that I mentioned before, because like you might be skipping over many frames. So the easiest thing for me, the easiest way I can think about is to do something like what I was doing before, where we say, if this is the first frame in this channel where we're controlling controlling turning is constant over the channel. If it's the first frame that we're evaluating the channel, then set the accumulator to, or set whatever the non-relative value is, and then diff off of that, right, every time. And so then if you skipped ahead 17 frames, you don't need to count up those frames in a loop. You could just like look at our current value, look at what the old one was, do the subtraction, and make that be the thing. Does that make sense, Casey?
So it does, although the way that I usually do this is I just sample the animation twice. So I just sample the curve at the previous t and sample the curve at the current t, rather than keeping the value around. But, you know,
yeah,
that may not work for the way, that may not be the way you have it set up. So keeping it stored is totally fine. And also, I was going to actually suggest, like, yeah, the way to do this in small steps is like, first just do the exact same thing you're doing before, which is keep a base, but keep the base inside the animation system, which sounds like exactly what you're suggesting.
Yes. So let me look at where I would do this. Where does it happen now? That is inside this place. Get xform state. It's a little bit, I guess this is an overload. It's getting an array of states. So this array is like one entry per bone. Xform state is, it's basically a transform, but it's a transform factored in the way that you want to for animation. So like if you multiply together everything into a big matrix, that like sucks for doing anything with. It's a terrible representation. And so this has like, oh, position is a vector 3. Rotation is a vector 4, or quaternion, right? Scale is a 3 by 3 with a flag about whether you're using the whole 3 by 3 or just the diagonal and whatever, right? And so those things help you animate. And of course, Casey knows all this. He's done this in a way more hardcore way than I ever have, because he really cared about the different applications might use different permutations of those values and care a lot about speed. Whereas for me, I kind of know which ones I'm using, and I don't. It's again that thing that I said before, like for Unity or Unreal, where if you're making code that's supposed to generally be used by everybody, it's much more work than if you're just making something that's fine for you, right? And so that's all. Like so Casey's done this he's put way more time into thinking about that kind of thing than I have. I claim.
Except I think my answer is basically the same as yours, so I think you were just better at it. Well, it took longer to get the same answer.
I mean, I do have wall clock time. Like I wrote my first animation system in like 1999 or whatever, right?
Yeah.
And I never have done the general library version, but I've done it for a few games in a few different ways. And like I've tried wacky ideas that I wouldn't want to re-explain here because they're stupid, and seen how they turn out and stuff. So
yeah.
I've done, I mean, I did animation for a game that nobody ever really saw. After the Hover Tank game, we made a barbarian sword fighting game.
Barbarian Smackdown.
Yes, Barbaric Smackdown was the name of it.
Barbaric Smackdown, sorry.
Yes. That was before I was a good game designer. And then I did one on, The Witness, obviously. I might have done, I did one in between. I did one for the gestural spellcasting game. Oh, and Happy Cake.
Yeah.
Yes, because we did, like, the giant mechs in Happy Cake were not skeletal animation. They were, like, all forward kinematics. But the player character was, right? The player character was like a dude playing run animations and stuff.
Yeah.
So
like a Space Marine.
So Happy Cake had an animation system, and that was actually the upgrade of the one for the spellcasting game. you know, so I've just done various iterations of this that weren't that hardcore, but they were enough for me to see what I was unhappy with, you know. Okay. You did funny stuff on Turok 2's animation system long ago. Yes. I don't remember what Turok 2 looked like, but those were the days. Okay, so this get xform state function, which is actually getting an array of transforms for the entire channel, right? So a channel is basically if you were playing one animation on the mesh. And because this is simplified, because I know I'm not doing like a bazillion partial skeleton like overlays and masks, this array is just like the size of the number of bones in the target mesh. Like I don't vary that up. There's no like cross-referencing indices to like scramble it around or any. It's just like, boom. All right. Probably nobody on the chat except for a couple people knows what that would even mean, but yeah. So, this is going to be a weird thing because I thought because of the little long explanation pair programming aspect, I would put this up on YouTube because it's probably educational. But like, I've really gotten very little programming done, like very little. So it's not a good YouTube. So I'm just putting this out there for people watching this on YouTube later. It's not going to matter because 99% of videos watched on YouTube only watch the first 7% of the video. But if you get this far, this is not a high level of programming productivity. Do not calibrate off this. Okay.
I can disconnect now, by the way. I was just hanging around. I'm sorry I ruined.
I don't know.
the
I think
productivity
people are
of the
having
stream.
fun with it. Does someone want to put up a straw poll on whether Casey should disconnect or not?
No, that's fine.
Or you could put a third option about what he should do in the poll. I don't know. Okay. I mean, if you want to like go read something or go to bed or like go play PUBG because that's such a great game, feel free to do any of these things.
Oh, PUBG.
Okay, now that I've lost, okay, so we had this turning control theta offset, which is the old thing. And that's just the absolute value. And so now I kind of just, I want to use this, but I just want to diff off it instead of, so we're going to rename this, but I'm going to, okay, we'll rename it as, I'm just going to call it base again. I don't know what to call things, so I just call them the same thing. It's fine. So we're going to do that. Right, and then in this case, minus turning control base, okay? So now we have the problem that we're not initializing turning control base. We can do that. So there's probably a place where we set animation. Oh, so this, right? So we might be starting the animation from the beginning, or we might be starting it from the middle. And usually that doesn't matter. The problem is now it matters, because what I was going to do is just say, you know, up here, I was just going to say, look, if it's not initialized, set it to the time equals 0. And like now it's like, well, what if somebody starts the animation in the middle? And my answer for now is going to be, yeah, no, you really do always want it from the beginning, right? So we're actually going to put that in set animation, though, instead of right there. So I'm going to make a note saying, regardless of where we start the animation time-wise, we always want to accumulate rotations starting at t equals 0, at least That's true for the Sokoban game. Other games might make other decisions. So this is something you might want to play with. Okay, whatever. Is not actually that helpful of a comment, but it is what it is. So the problem is now, okay, we got an animation, and well, we know the number of samples is greater than 0. So we're going to look at supplement 0. This is the data besides the animation data. This is like ancillary data that we've computed. And we're going to say theta relative to start. And that is just going to be, turning control base equals that. And this is only if anim.controls turning, we're going to do this. Or maybe we should do it always, because like, I don't know. I don't know, man. I just work here. So, and it's not, I mean, I do. Like, honestly, so here's the thing. Like, I work hard on games a lot of the time. I really care, especially to design games to a large, both deeply, so that they're deep and interesting game design, or at least to the greatest ability that I have, which I'm not claiming is better or worse than anyone else's, but deep, but also trying to be meticulous and pay attention to detail. It takes a huge amount of effort. And my problem right now is I'm working on too many things to realistically do that. So that's going to have to change at some point so that I can really zoom in on stuff and make it good. But like, literally, I do almost have an I just work here attitude sometimes, where it's just like, look, I just got to do something here because I've got 17 other projects.
So I feel like you're kind of doing this wrong. I think the current way to do it is more like, look, COVID-19 update. We would normally be doing an exemplary job on all of this code, but we have had coronavirus-related setbacks, and that is why the animation is currently screwed up.
Yes, nobody could have foreseen that there would be coronavirus-related setbacks. But
no, absolutely not.
Nevertheless, they're here. No, and it's actually not true. Like, I'm kind of biphasic this way, where like right now I'm not digging into it that deep, and the fact that I'm streaming is probably part of it. But like, sometimes I'm just like, look, I know there's clocks ticking on all these projects, and that's very stressful. I'm just gonna like turn off the clock, or like put it in the dresser drawer and just work on this thing for a week and make it really good. Like this one particular like thing. And it may not be obvious that that's a good thing to do, but to me, it's really good for many reasons. Not least of which is that you maintain your sense of self-respect, that you're an actual craftsperson who is good at what you do. But also, like there's a danger, like I'm sloppy sometimes in order to get things done. But that's supposed to be temporary. That's not supposed to be who I am. But if you do that all the time, it kind of becomes who you are because you don't practice anything else, right? So sometimes you need to practice, even if you feel like you don't have time, you need to practice being Jiro the sushi maker. You know, whether it's about design or code or whatever. You know what I'm saying?
I feel like there's also like a thing that it's hard to appreciate, I think, until you've worked on too many projects at the same time and been stressed. But I feel like there's a thing that's something like if you imagine the RPG analogy, like sometimes you just have like your mana is fully charged, but you like accidentally dropped all your weapons or got disarmed. And so like, even though casting a spell is not what you're supposed to be doing and you're supposed to be like meleeing this thing, you can cast a really baller spell right now. And so the sum total of like what the world or your company gets out of you casting the spell, rather than meleeing with your bare hands, is just like way higher. So sometimes you have to take the fact that your brain can't just arbitrarily choose to do a particular task at the highest level of efficiency. Because maybe like right now, it really, I mean, in your case, like maybe it has like a ton of design power at the immediate moment and not that much programming power. It's like, don't dig into a programming problem. Do the least you can on the programming problem, switch over to design and do like a great job on the design. That's just a better decision at that point. You know what I mean?
Yes. Or even, I mean, there are many layers to this, right? So
yes,
like there's different kinds of programming. Some programming is, I really need to think of a way to architect this system that's going to be clean. Like the current thing is kind of works, but I don't totally trust it, and it's hard to think about, and so I need to figure out a better way to do it. Or maybe you need to figure out a way to do it initially because you don't even have an initial implementation. Those things happen all the time, but sometimes it's just like I've got to grind through some stupid features that aren't that, they're like not hard to think about, right? Or I need to debug some things, but they look like stupid bugs that are easy to find. And if they don't turn out to be easy, I'll just postpone them till later, right? And you can do one or the other of those depending on where you are mentally right now, right? And it's a good way of staying productive, right? And the key is just, do you want to work or not? Like if you want to work, you will find the right things. Or I mean, it's a talent that you have to build, I guess, but you'll be able to find the things that are good to work on right now. Whereas if you don't want to work, you'll use that as an excuse. Like, oh, I can't really think about this hard problem right now, so I'm just going to go watch TV or something, right? Or I guess Netflix now. There's no TVs. Even though there's this giant pile of easier problems, you also kind of dread those because it's this giant pile that's getting bigger every day, and you're like, oh my God, I don't even want to think about that, right? I'm going to go watch Netflix. But actually, it feels good to make that pile shorter, honestly, usually. And that can help motivate you too. Is like, yeah, I just sat down and like, oh my God, look at all the things I knocked off that pile. Never mind that it's only 5% of that pile. If I do it 20 more times, I can do that. 20 reps. Who can't, do you even lift? You can do 20 reps.